Welcome to EDU World Space.
Hello. In this problem, we're asked to derive how much more severe a automobile crash is between one car and another car given in a previous problem. Now, what is severity? So in this problem, we're given a definition of what that means, and so what we're told is that the severity of a crash is given by energy, the energy absorbed in a collision, divided by the energy absorbed, oops, in a test case. In this case, it's a test case of just another automobile crashing into a wall at some velocity v naught. So, in the previous problem, we're given many definitions on what the energy absorbed means. What we're told is that the energy absorbed that's talked about in the problem is that is measured in a reference frame moving along with the center of mass of the system. And because it was a plastic collision, we know that in the end, the system will have no kinetic energy because the cars will stick together and will then be at rest because we're moving in a reference frame, that's moving at the same as the center of mass of the system. That means that the amount of energy that either car absorbs is given by 1/2 the amount of momentum it had prior to so say that this were for car A, the energy absorbed by car A is given by the momentum it had before the collision squared, right? And then all divided by the mass of car A. So if we want to figure out the severity of an accident that would occur for car A, right, we would take, that energy, we'll do the severity, T, for car A is going to be the energy absorbed in the collision, again, right up here, and then that's compared to the energy absorbed in a collision where the object was going at a speed of v naught, right? So no matter what, in the test case, the car is going to hit the wall, it's going to end up at rest, and that means the energy absorbed in the test case is going to be given by the kinetic energy it had prior to hitting the wall, right? So we calculate the severity for car A by using the momentum it had prior to the collision, dividing that by 1/2 in the mass of the car, and we get this ratio here, and that gives us the definition for the severity of the impact for car A. Now, very similarly, the severity of the impact for car B is just going to be the energy absorbed by car B divided by the same energy. Oh, actually, if we need to specify here, the same we need to specify the correct masses here. So this would be mass A for severity A. This would be mass B for severity B. B naught squared. That ends up being 1/2 PB, right? The amount of momentum car B had prior to the impact. Let's see, divided by mass B, all divided by, again, the energy absorbed in our test case. So we do a little simplification here. And what do we get? And top here for severity A is going to be the momentum that car A had prior to collision squared, divided by the mass of A, all squared, divided by the velocity squared, right? Because the halves cancel here in our two masses multiply in the denominator, and B naught stays in the denominator here. And as you might expect, we get a very similar expression over here for severity B. Thus, we are asked, do a little section here, we are asked how much more severe is the accident for automobile B compared to automobile A, right? So what that means is we want to find the ratio of the severity of the crash for automobile B to the severity, sorry, my E is a little hard to write with this pad, severity of car A. Well, we know expressions for those now, right? And move down a little bit here for the for the space I have. Severity B, right, is going to be momentum B squared divided by, let's see, b squared, v naught squared, sure. And then we're going to divide that by severity A, pa squared divided by ma squared, v naught squared. Now, one of the major things we have to remember, right, is that all of this is defined in a reference frame that's moving at the same speed as the velocity of the center of mass of the system that combines both car A and car B. What that means is that, and since it's a completely plastic impact, like I said before, once these two cars collide, they will be at rest in this reference frame. That must mean, right, that the total momentum is zero in this reference frame. And that must mean that the momenta must have been equal and opposite prior to the impact. Of course, what does that mean? That means PA squared is equal to PB squared. And that means this cancels with this. And of course, V naughts are the same as well. Those cancel with each other. And so that means if this is going to be 1 over mb squared divided by 1 over ma squared, which means this is ma squared over mb squared, flipping the reciprocal. And we just bring our squared out to match what we see in the textbook, and we see that the answer, so how much more severe is that the accident is for car B compared to car A, is the ratio of the masses of car A to car B all squared. And that's it.